Hello everybody and welcome to a new video in the series of Python. So if you recall, in the previous video we talked about strings, how do we manipulate strings in Python, how do we work around strings. Before that we talked about variables and different data types. So in this particular video we're going to talk about lists and tuples in Python, right? So without further ado, let's go quickly to our Jupyter notebook and let's create a new Python notebook and let's get started. So let's rename this as lists and tuples. Yeah, okay. So if you think about it, a string is basically a collection of characters, right? A list is pretty similar, except that it's a collection of objects of different data types. Because when we talk about a string, everything is a character, right? You have a bunch of characters after each other as follows. Let's say I put my name first. Then I put my age, which is 23. I put my favorite subject, which is maths. Then I put a float value, let's say 22.7. And let's say I put a Boolean type as well, true. Now, if I print this, you'll see that you'll see that it returns the list, right? So you have a bunch of different data types over here. You have a string, you have an integer type value, you have a float value, also a Boolean value, right? So that is one fundamental reason why we choose to work around with lists rather than strings, right? But if I had to draw a comparison between lists and strings, so if I use my name, for example, or let's go with this string, okay? So let's go with string ABC. Let's say ABC. This is exactly the same as this particular list. I could have a list which has A, B, and C as different, elements of this particular list, right? So these two work exactly the same. I mean, from the appearance it might look different, but if you think about it, they're pretty much the same, right? So a list is basically going to take the characters of a particular string and put them in order. So you have to remember a list is always ordered, right? So that's the idea. So yeah. So a few functions work the same way for strings as well as lists, okay? For example, let's go with the same list. Let's define this to be L, and if I print the length of the string, the length of this list, I'll use the same function, right? And if I run this, you can see that it prints 5 because there are 5 elements in this, right? 1, 2, 3, 4, 5. So this is one feature. Second thing is accessing elements of a list works the same way as accessing elements of a string, right? So even in this case, the indexing starts from 0 all the way till the length minus 1, right? So if I print L of 0, let's go with this. Let's print L of 0. So again, remember when we want to access elements, we use square brackets, right? So L of 0. And if I run this, you'll see it prints shame, right? If I go with L of 2, and if I run this, you'll see it prints maths, which is like the second. The position is 2, right? 0, 1, 2. So that's maths, right? So it works the same way as accessing characters of a string, right? One more thing you can do with a list is you can arrange a list in an ascending order. So that's known as sorting, right? So there's an inbuilt function in Python which deals with sorting a particular list, right? So for example, if I add let's add a new cell. Yeah. So let's go with this particular list, okay? Let's define L1 to be a bunch of characters or strings, whatever you want to call them. C, then D, then A. And let's put a couple of random terms in between. Let's say F over here, then E over here. And let's say this is my list, okay? So it's a bunch of strings. And let's say I sort this. So L1.sort, that's the function we use for sorting a particular list. If I use this and then I print this new list, L1, let's see what happens. So if I run this, you'll see that the strings are arranged in alphabetical order, right? So you have A, C, D, E, and then F, right? So I could also work with numbers, for example. I could work with 5, 3, 2, 1, and then 4, okay? And then if I sort this, and then I print this new list, let's see what happens. So L2, and then I run this. So you can see that they're arranged by default in an increasing order, right? So for numbers, it's going to be an increasing order. For characters or strings, it's going to be an alphabetical order, right? So you can sort it. You can also reverse a particular list, okay? So let's go with this. Let's add a new cell over here. Let's print this. let's call it L3, or it doesn't really matter. I mean, every time. So one more thing about Python is if you're using the same variable name multiple times, the last instance when you use it, that's the one that Python is going to remember, right? So for example, if you assign a equal to 5, then a equal to 7, and then a equal to 12 in the last line, Python is going to remember the last value, right? So you can use same variable names multiple times. For example, like this, when you're giving an example to somebody, it doesn't really matter, right? As long as you're not using the previous values again. So if I go with L3 equal to this, and then I put L3 dot reverse, and then if I print L3, let's see what is the output. As you can see that it's so you can see it's in the opposite order, right? So it's 4, 1, 2, 3, and 5. It's in the opposite reverse order, right? So you can directly reverse a list. If you compare Python with other basic object-oriented programming languages, for example Java, reversing a particular list would have been very difficult when it comes to Java, right? You would have to individually access the elements of the particular list or set, whatever you want to call it. You would have to append that to a new particular set, and then you have to print the new set, right? Compared to that, Python has a lot of inbuilt functions for making these simple tasks way easier for you, right? So that is why a lot of the advanced stuff happens in Python, right? We'll come to it towards the end of this playlist when we give you examples how we use Python for machine learning programming and so on and so forth. So you can understand like why we prefer Python over other object-oriented programming languages, right? So a few other functions that you can use is append, okay? So what exactly is appending? So let's take a very simple example. Suppose you're a teacher of a class, you have a bunch of students in your class, and you have the names of your students in a particular set or a list. So let's call it name. Let's say the names of the students are let's say A, F, D, and E, okay? Suppose these are the students that are already present in your class, and let's say a new student, let's call his name C, takes admission to your class, and you want to add his name to it. So what you can do is you can just append it to the end of this, okay? So name.append, let's go with C, okay? And then if I print name, let's see what happens. You can see that C is added, but the problem with this is it gets added to the end of the list, right? But in general, what happens in schools is registrars and other things, they are arranged alphabetically, right? So if you want to arrange it alphabetically after this, given that your original list was alphabetical or maybe not, it doesn't matter. You can just use sort after this, right? So you add it and then you sort it out, right? But say there's a case where you actually know at which position in the list you want to append your thing, right? So for that, what you can do is you can use insert, right? So if you want to insert it, let's go with this, same example, let's go with name. And let's say I want to insert it at some position. Let's say the third position. And then if I print this, you can see that 0, 1, 2, 3, the third position is going to be occupied by C. So if you know at which position or which index you want to add the new element to, you can use this function known as insert, okay? So that by default will add your new element to that particular index. After this, you also have options of removing elements, right? So for example, let's again work with this. And let's say you want to pop some element, right? So what is popping? So when you pop an element from a particular list, it basically removes the element and it shows which element it has popped, right? So you could go with name.pop, which index? Let's go with 1, right? So when you pop something, you have to give the index that you are popping out, right? For example, I popped the element at index 1, and when you pop something out, it will tell you which element has been removed, right? But let's see what happens after you pop it, okay? So if I remove this and I print name after this, as you can see, it's no longer present in the original list, okay? So pop by default removes it, it tells you which element it has removed, and then it basically gives you the new list, right, after removing. But now let's assume that you don't really care about which element you are removing, because you know which element you want to remove from the list, right? So unlike pop, in case of pop, we did not know which element we were deleting, right? We were deleting it from a particular index, right? But now let's say you are looking for one specific element from the list that you want to remove, right? So in that case, what you use is you use the function remove, and if you work with the same list, you can use this, and let's say name.remove f, okay? So after remove this, let's print this as well, and let's see what happens. So as you can see, it removed F, okay. So the basic difference between popping and removing is, for pop you're popping the element from an index. You don't know what the element might be, right? You only get to know it after you pop the element out. But in case of remove, you know which particular element you want to remove from your list, right? So that is the primary difference. So this was all about lists in Python. Compared to this, you have another feature which is known as a tuple in Python. So what exactly is a tuple? So unlike a list which works between square brackets, a tuple is put inside first brackets. Okay, let's go with 1, 2. So this is what a tuple looks like. So unlike lists and strings are known as mutable data types or mutable variables in Python. Why? Because mutable is basically something you can change, right, while you're working around with it. A tuple, unlike lists, cannot be changed, okay? If you predefine a tuple, you can't mess around with it. You can gather information from it, whatever you want to know from it, but you cannot really change elements inside it. You can't really change the order of the elements, okay? So that's the primary difference. So you can go with length of a tuple. If I run this, you'll see that it turns out to be 2 because there are 2 elements. The other feature you can do is you can count from a tuple, right? So if I add a new cell over here, let's go with b equal to 1, 2, 3, 4, 5, 4, and so on and so forth. I mean, it could be anything. You can count something, which is like the first time a particular number occurs in a tuple, right? So if I go with a.count 4, it's b.count. Let's go with b.count. You can see it basically tells you the number of times a particular element occurs in a tuple, right? For example, 4 occurs twice, right? So you can count the number of times a particular element occurs in a tuple, right? These are mostly the 2 features we use when we are talking about tuples in Python. But apart from this, being immutable, it's not really very useful if you're working around with tuples, okay? You can't really add elements to it, you can't remove elements, so it doesn't really matter much, right, if you work around with tuples in Python. But these are 2 basic, in some sense, these are the equivalents of sets, okay? So you can store a bunch of things inside a tuple and a list and you can work around with them. So if you like this video, please let us know in the comments and stay tuned for the next video.